Hi everyone, it's Loic controlsnyc. Welcome back to another video. I'm going to be explaining the basics of building management systems. What is a building management systems? Building management systems, or BMS, is a way to get many different systems of a building, such as air conditioning, water cooling, security, lighting, and more, to work together by communicating across a common framework. This helps buildings be more efficient and consume less energy. As you might know, many BMS companies and devices work with Niagara 4, which is a framework that helps different systems and protocols work together. A protocol is a sort of programming language. One example is BACnet. BACnet stands for Building Automation and Control Networks. So BACnet is to Niagara what a language is to an interpreter. There are many other protocols used in BMS, such as LAN, Modbus, and KNX. However, BACnet is much newer and more complex than most of these protocols, therefore it's more widely used. So while you might see some of these other protocols being used for simpler or older systems, the majority of the time you're going to be dealing with BACnet. Additionally, some of these other protocols only work on one brand or sets of devices. They're not interoperable between all devices. However, BACnet is able to communicate across nearly all devices, which is only facilitated by Niagara. Therefore, almost all devices are BACnet compatible. For example, Honeywell, a major producer of HVAC hardware and components, makes all their products with a BACnet MSTP port, which I'll talk a little bit more about later on. A little history. BACnet was designed by ASHRAE, or the American Society of Heating, Refrigerating, and Air Conditioning Engineers, specifically for building automation and control networking, and it's used as the ASHRAE standard. It's been designed specifically to meet the communication needs of building automation and control systems for applications such as heating, ventilating, and air conditioning control. But there are different kinds of BACnet. The two main types are BACnet MSTP, which I talked about earlier, and BACnet IP, but there's also BACnet Ethernet and BACnet SC. As you could probably figure out, each type works through a different medium, a different port. MSTP, IP, Ethernet, and SC. IP works through IP addresses, Ethernet works through the Ethernet, SC is an encrypted version, and MSTP stands for Master-Slave Token Passing. What does that mean? Well, in an MSTP connection, there's a master device and a slave device, multiple slave devices. In this context, a master is a device which can initiate a service request, and a slave is only able to send responses through signals. The master device needs to have a token, this is why it's called token passing, in order to issue a request, but a slave does not need a token in order to issue return reply. I said earlier that IP and MSTP are the most commonly used. So what are the pros and cons of each? IP controllers are generally faster than MSTP. Additionally, IP has the potential to act as a standalone controller, where they have graphics built into them, they have trending, alarming, all sorts of more advanced capabilities. They don't need to rely on a master controller to make them communicate, so if the connection to a supervisory device goes down for whatever reason, you could effectively run that air handler or chiller or whatever it is that you're controlling and all of its sub-devices off that advanced application controller. However, MSTP has a few advantages. It's generally a bit cheaper than IP products because they're a little older and the wires are cheaper. Additionally, it's known to be reliable and has good longevity. Overall though, IP is the emerging technology, and it's only a matter of time before most controllers and systems run with IP until another system is invented. So BACnet is the protocol for a system. It's how controllers and devices communicate. Think of it as a hierarchy. Protocol is the highest order, the communication. Then automation devices, such as routers and controllers. Then field devices, which sensors and actuators and valves. And all these devices act based on orders from controllers, which communicate through BACnet or whatever protocol they're using. However, each device acts in a different way. Some of them, like sensors, give information to the controllers. Others, like actuators and valves, receive orders from the controller. This is the difference between inputs and outputs. Inputs send information, outputs receive information. Then let's think about the types of information that devices can work with. In BMS, we're really only using analog and binary, which is also known as digital. Analog is a number, such as a temperature reading or an angle measurement. Binary or digital information is a yes or a no, a true or false, a 1 or 0, an open or closed. It's one option out of two. So let's apply this to inputs and outputs, which are also called I/O, by the way. So an example of an analog input would be a temperature sensor telling the controller how hot some water is. An example of an analog output would be a damper being told to adjust its angle by 30 degrees, since it's acting based on what the controller told it to do. An example of a binary input would be a smoke detector. Either it detects smoke or it doesn't. So it sends a signal to the controller, I detect smoke or I do not detect smoke. An example of a binary output, which is a little rarer, would be a damper that can only either open or close. There's no in between. It's either open or closed. However, a controller can't accept an unlimited amount of inputs and outputs. Many of them have a certain amount of each type. For example, a controller might be able to handle 10 universal inputs, also known as UI, so either binary or analog, plus 4 designated binary inputs, with 4 possible analog outputs and 8 binary outputs. However, some controllers have possible attachments in order to expand the amount of inputs and outputs that they have. So that's the basics of BACnet and how a BMS system works. This should be a good base for you to understand the way that BMS works. I hope you found this informative and helpful. Please consider subscribing to our channel, and thank you for watching.